Okay. Good evening, everyone. My name is Chandan Kumar Gupta. I am a Prime Minister Research Fellow in Department of Mathematics, IIT Patna. I am your NPTEL PMRFTA for the course Probability and Statistics. This course is offered by Professor Somesh Kumar. He is a faculty in IIT Kharagpur. Okay, so this is the 12th week of a 12-week course. You may say that it is the last lecture of our 12-week course. Okay. Arya, you want to say anything? Because you are not audible. Yes, yes, your voice is not audible. Okay. Okay, if you have anything, you people may ask. So in this week, we will discuss about the testing of hypothesis for the normal population, like for the normal mean, when sigma square is known and when sigma square is unknown. Also, we are going to discuss about the testing of variance when mean mu is known, when mean is unknown. We'll also work for test for proportion. We're also going to discuss about the two sample problems, like when we are given xi's and yi's, two random variables which follows normal distribution. Then we need to test the difference of means, test for the difference of means, also for the same for the difference of variance. Okay, so just let's have a recap about this topic first. Anyone have any doubt? Then please ask. Okay, like we are going to test about the normal distribution. Okay, so test for normal distribution. Usual notation is like it is a normally distributed with mean mu and variance sigma square. Okay, so let like x1, x2 up to xn. These are random variables which follows normal distribution with mean mu and variance sigma square. Okay, so there are different scenarios. The first one is like we are going to test for means. Test for mean. Okay, so there is two conditions like case one, when sigma square is known, or case second, when sigma square unknown. Okay, so in testing of hypotheses, there are four processes. Okay, the first one is like frame the hypothesis. Then we are discussing about the test statistics, and then compare the test statistics value to the tabulated value for the true value, and then conclude our result on the basis of these tabulated and calculated value. These are the four steps. Okay, so like when we are discussing about the testing for mean when sigma square is known, then in that case our test statistic will be z, which is x bar minus mu on sigma by root n. Okay, since we are known, so it is known, suppose it is given sigma naught square, it is any value of sigma square. Okay, so we may write like sigma naught square here. Okay, and in case when unknown, then we define the statistic t, which is equal to the similar manner x bar minus mu upon, since sigma is not given, so we use some statistic of sigma, which is here like S, sample variance. Okay, and the sample variance is like 1 upon n minus 1 whole square. Okay, so this is the two conditions, and the test statistics is defined in such a way. Okay, and since we are discussing about the hypothesis, our aim is to first define the hypothesis. Okay, so there are three types of hypothesis possible. The first one is like simple versus simple, simple versus composite. Okay, and composite versus composite, these type of hypothesis. So suppose we define the null hypothesis in this case. In this particular case, testing for mean, our first hypothesis will be like H naught, that is mean, mu is less than or equal to mu naught. Okay, or we say that equal to mu naught. Both have the similar meaning or have the similar test. Okay, against mu is greater than mu naught. Okay, in this case, H naught is rejected, or we reject H naught. Okay, reject H naught if in this particular case, Z tabulated and Z calculated, Z is like greater than Z alpha. Okay, greater than or equal to have a kind of similar meaning because we are dealing with the continuous distribution. Okay, so like this. Okay, or if if sigma square is unknown, in that case T is greater than T n minus 1 alpha. Okay, so we use the T or Z table and the calculated table from here and here and check whether we get the values, either this relation holds or not. On the basis of this, we reject either H naught or we fail to reject H naught. Okay, we will discuss about the questions as well. Just a brief intro about these things. Okay, second case will be like this, na? H naught, such that mu is greater than or equal to mu naught. Again, it is equal to terms is also included versus H1 such that mu is less than mu naught. Okay. In this case also reject H naught if Z is less than minus times of Z alpha and T is less than minus times of T n minus 1 or alpha. Okay. So we need to check which type of hypothesis we are going to test. Okay. On the basis of that type, we will either follow this or the third condition, which is the null hypothesis mu equal to mu naught against the alternative hypothesis mu is not equal to mu naught. Okay, here in first and second, it is kind of one tail actually. It is also one tail, but it is a two tail. Okay, it is a two tail. So this should also be keep in mind while discussing about the testing of hypothesis. Okay, so in that case, when we are discussing about the third scenario, like okay, we reject H naught if Z, we use the mod Z. Okay, Z is greater than or equal to like Z alpha by 2, or in a similar manner, T is greater than or equal to T n minus 1 alpha by 2. Okay, these alpha by 2 are come because when we are discussing about the single term, then either this is alpha or this is alpha, either this or this, not both. Okay, but when we are discussing about dual tail, like this is also, this is 1 minus alpha and this is like alpha by 2 and this is alpha by 2, so we use this. Okay, in a similar manner, like test for variance also. Test for variance, again there are two possibilities, like when mean is known, when mu is unknown. So when mu known, in that case we define the test statistic W, which is defined as like this: summation xi minus mu naught whole square upon sigma square. Okay, we are going to discuss about the testing for variance when mu is known. Okay, So this, and when case second is like when mu is unknown. In that case, we define the test statistic, suppose it is W star, and it is defined as like n minus 1 capital S square upon sigma square. Okay, and capital S square is again like is 1 upon n minus 1 square. Okay, so this is capital S square. Okay, and in the similar manner, we check the values. Since it follows chi-square distribution, we check the values of chi from the chi-square table under the degree of freedom, and then work accordingly. Like again here, there are three possibilities for hypothesis. Like first H naught, that is null hypothesis. Sigma square is less than or equal to sigma naught square, or equal to sigma naught square. Against the alternative hypothesis, sigma square is greater than sigma naught square. Then in this case, we reject H naught if this W which we have defined here, the statistic value is greater than or equal to chi square with n degree of freedom at alpha level of significance. Or when mu is unknown, in that case, this W star value is greater than or equal to like chi square with n minus 1 degree of freedom at alpha level of significance. Okay. Again, in a similar manner, if the hypothesis is defined like this, it is greater than or equal to sigma naught square, versus alternative hypothesis is less than sigma naught square. Then again reject H naught if our W is less than or equal to chi square. It is n degree of freedom, and it is 1 minus alpha level of significance now. Because chi-square distribution is not a symmetric distribution. In the upper case, like when we are discussing about the Z, like the test for mean, then Z is or T, it is a symmetrical. So we use the negative. But here it is either alpha or 1 minus alpha. Okay. And also in the similar manner, W star value is less than or equal to like chi-square. 1 degree of freedom is lost. So n minus 1 at 1 minus alpha level of significance. Okay, and the third possibilities will be like the null hypothesis is sigma square equal to sigma naught square, versus sigma naught square, not sigma square is not equal to sigma naught square. Here again, the first two are single tail or one tailed, and the last one is the two tailed. Okay, so and also the first and second are composite versus composite hypothesis testing, but the third one is simple versus composite hypothesis. Okay. So reject H naught if W is greater than or equal to like chi square n alpha by 2, and or W star is greater than chi square n minus 1 and alpha by 2. Okay. Since again it is double tailed, so like in a similar manner, suppose it is alpha 1, it is alpha 2. Okay. But for the sake of simplicity, we take it alpha by 2 and alpha by 2.
Excuse me, sir.
Okay. Yes. Hello.
In the last line,
Yes.
this alpha by 2 or 1 minus alpha?
It is alpha by 2. No?
1 minus 1. Okay,
Actually we have considered like this, no? So we have just for notation purpose, it is alpha by 2 and it is alpha by 2. Okay.
Okay, sir.
It is alpha 1, it is alpha 2. It may equal or may not be equal. So that's why. Okay. We will solve the questions and then you will definitely got this. Okay. Now the third one is like test for proportion. Okay. Now the test for proportion, in this case, like the null hypothesis is defined as, suppose P, which is the proportion P naught against P is not equal to P naught, suppose. Okay, then the test statistic is defined as like P minus P naught upon, like, it is P naught, Q naught is nothing but 1 minus P naught, and it is N. Okay, so this is the test statistics. We find out this value, and then again reject H naught if the calculated and tabulated value are. So if the calculated value is greater than or equal to this, then we reject H naught, the null hypothesis, otherwise we accept. Okay, like in a similar manner, we can also, for two sample problem, like for two sample problem, okay, like difference of mean. We are discussing about the difference of mean. Okay, so in this case, like x1, x2 up to xn, yeah, xn1, for example, x11 follows normal mu1 sigma 1 square. Similarly, y1, y2 up to yn2 follows normal mu2 and sigma 2 square. Okay, in that case, when we discussing about the difference of mean, okay, so there are three possibilities. Like the first possibility is, suppose sigma 1 square and sigma 2 square are known. Second one is both are unknown and equal. And the third one is both are unknown and unequal. Okay, so in these three scenarios, we define the test statistics in a three different ways. Like when sigma 1 square and sigma 2 square are known, in that case, the Z statistic, suppose it is Z1, it is defined as like x bar minus y bar and divided by sigma 1 square upon n1 plus sigma 2 square upon n2. Okay, this is the test statistics. Okay, second case will be like when sigma 1 square and sigma 2 square unknown. Unknown, but there are also two possibilities, like but equal. Sigma 1 square and sigma 2 square unknown, but they are equal. We have only this information. Then in that case, the test statistic is defined like it is T1, which is it's n1 n2 upon n1 plus n2, which is in under root. Then it is multiplied by x1, sorry, x bar minus y bar. Okay, and then it is divided by sp. Sorry, divided by sp. Okay, where sp is defined like this. Sp square is like n1 minus 1 s1 square plus n2 minus 1 s2 square and whole divided upon n1 plus n2 minus 2. This is how sp will be calculated. Okay, and the third possible case is like when sigma 1 square is not equal to sigma 2 square. Okay, and unknown. That means the sigma 1 square and sigma 2 square are unequal and unknown. In that case, the test statistic is defined like this. Suppose it is T2. So it will be like x bar minus y bar. It is divided upon s1 square upon n1 plus s2 square upon n2. Okay, and this follows actually T distribution with new our degree of freedom. And this degree of freedom will be calculated with the help of like this. Your nu will be calculated like S1 square upon N1 plus S2 square upon N2 whole square term and divided by S1 to the power 4, like S1 square to the square, that is S1 to the power 4 upon N1 square, N1 minus 1. And similarly, S2 square to the square, like S2 to the power 4, it's N2 square, N2 minus 1. So this is how nu is calculated to its nearest integer. Okay, the nearest value of integer nu will be taken as at that degree of freedom, and then we use the t table to find the value of the tabulated value of t, and the calculated value of t is calculated with the help of this formula, and then we conclude. Okay, so these are the cases. Although there are also hypotheses, there are 3 types of hypotheses are also in this case. The first one is like composite versus composite. That is our null hypothesis defined like this: mu1 is less than mu2. Okay, or we say that mu1 is like this equal to versus its mu1 is greater than mu2. Okay, in this case we reject h0 if z1 is this statistic which we have defined when sigma 1 square and sigma 2 square are known. Okay, in that case z1 greater than or equal to z alpha at alpha level of significance. When we are discussing about the second case, when sigma 1 and square and sigma 2 square are unknown but equal, in that case our statistic is t1, and t1 will be like this. Okay, so t, the degree of freedom will be like n1 plus n2 minus 2 and alpha. Okay, so this is our t, the degree of freedom. Okay, and in case the third scenario, both the variances are unequal and unknown, our statistic is t2, which is like greater than or equal to t, and in that case the degree of freedom is nu. Okay, so degree of freedom nu and alpha. Okay, so in all the 3 cases, when we are discussing about this hypothesis, this first case, then we will conclude our result on the basis of this, whether the null hypothesis is either accepted or not accepted. Okay, second scenario will be like, suppose null hypothesis defined as like this: mu1 greater than or equal to mu2, or equal to also is there, and again the alternative hypothesis will be like mu1 is less than mu2. Okay, then in a similar manner, these all are already discussed in the lectures. I just tried to write the formula so that we can solve the numericals on the basis of these formula. Okay, so like reject h0 if again in case z1, we are discussing about the z1, then the value of z1 is less than or equal to mod of z alpha. Okay, not mod, sorry, negative of z alpha. And when we are discussing about t1, it is less than minus of its n1 plus n2 minus 2 and alpha. And the third case, when unequal and unknown, in that case t2 minus times of t nu and alpha. Similarly, and the third scenario, when our h0 is mu1 is equal to mu2 versus mu1 is not equal to mu2, two-tailed. So in this case, we reject h0 if since t and z distribution are again symmetrical, so we can write like this: mod of z1, the statistic value, is greater than or equal to z alpha by 2 here, or t1 taking a mod greater than or equal to t n1 plus n2 minus 2 alpha by 2, and if t2 similar manner nu alpha by 2. Okay. And for the sake of simplicity, like we always discuss, like any kind of problem can be either framed in this form or this form. Okay. So try to make one particular form, and on the basis of this, you either write like learn about this or this, whichever you got comfortable. Okay. Again, there are okay, like there are paired t-test also there. Let me write. Let me write it a little bit fast. Paired t-test. Okay. Pair, in case of paired t-test, like the t statistic is defined as like this. Suppose we can write t star because t is already written. And root of n, it's d bar, it's upon sd. Okay. Where like di is defined, since it is a paired t-test, so there are xi's and yi's, and xi and yi have the same number of samples. So it is xi minus yi, d is defined like this. So d bar is nothing but like 1 upon n summation of, it's not xi, it's di actually, which is xi minus yi. Okay, and sd is again like sd square is n minus 1 summation di minus d bar whole square. Simple. Okay, I from 1 to n. So this, so again like h naught is defined like this mu d. Mu d is d like less than or equal to 0, where mu d is defined like this mu1 minus mu2. Okay, so either this against like h1, so mu d is greater than 0. Okay, so in that case, like reject h naught. We are already always discuss about the null hypothesis. Okay, our aim is to find the reason in which we fail, we reject the null hypothesis. Okay, so reject h naught if like the statistic is greater than or equal to t, it's n minus 1 alpha. In a similar way, we can write is less than, then it reciprocal, like the sign is inverted. And in case of equal, we take the modulus value, similar, and alpha is converted into alpha by 2. Okay. Also, there is one more thing. Let me write the last one. There are three possibilities. I'm not going to write actually. Okay. These are already discussed. And the last is like testing for two variants. Okay. Testing for two variances. Okay. When mean is not known, in that case, we are discussing like the statistic is defined like this. F, which is like S1 square upon S2 square, when S1 is 1 upon N1, 1 upon N1 minus 1, summation xi minus x bar whole square, and y, suppose S2 is belong to y2, and a similar formula. This is, and this follows the F distribution with N1 minus 1, N2 minus 1 degree of freedom. Okay. Also, since when we are discussing about this, we take the numerator, the larger value is taken in the numerator. So here in that case, S1 square is greater than S2 square. Okay. Or if S2 square is greater, then we just put the numerator, S2 square in numerator and S1 square in denominator. Okay. So again, like three possible hypotheses will be like this. Okay. Okay. Three possible hypotheses like the null hypothesis. The first, like sigma 1 square is less than or equal to sigma square. Okay. So in that case, like reject h naught if f, the calculated value f is greater than the tabulated value. Let me write the tabulated value like this. F with degree of freedom n1 minus 1 N2 minus 1 and alpha level of significance. Okay. Sorry, let me write the alternative hypothesis as well. Okay. The second case will be like the null hypothesis sigma 1 square is greater than or equal to sigma 2 square against the hypothesis sigma 1 square is less than sigma 2 square. In that case, we reject the hypothesis, the null hypothesis, when the calculated value is less than f of n1 minus 1, n2 minus 1, and it's 1 minus alpha. Okay, because f is also not a symmetrical in nature. And the last possibility will be like sigma 1 square equal to sigma 2 square against sigma 1 square not equal to sigma 2 square. In that case, we reject the null hypothesis H naught if like f is greater than or equal to n1 minus 1, n2 minus 1, and it is alpha by 2. Okay, again like alpha 1, alpha 2, and we, for sake of convenience, alpha by 2. Okay, so these are the things we have discussed in the 12th week lecture. Okay, now come to the numerical part. Anyone have any doubt? Then he or she may ask. Okay. Okay, the question one will be like, suppose a telecom service provider claims that a telecom service provider claims that individual customer pay on an average 400 rupees, okay, per month, with standard deviation of rupees 25. Okay, okay, these are the information we are given. A random sample of 50 customer bill, a random sample of 50 customers bill during a given month is taken. During a given month is taken. Okay, with a mean of, and we find out the with a mean of 250 and the standard deviation of 50. Okay, now what to say with respect to the claim made by the service provider? Okay, what to say with the claim made by the service provider at 5% level of significance. Okay. Here we are given a telecom service provider. It claims 400 hours, 400 rupees. An average customer pay 400 rupees per month with a standard deviation 25. Okay. And when we take some sample of 50 customer and find out that the sample mean will 250, and the standard deviation will be 50. We need to check, okay, that the claim that service provider made, that it is 400 hours, is either true or not. Okay, so our first 4 steps will be like, first try to frame the null first try to frame the hypothesis. Okay, then the statistics will be calculated on the base of hypothesis. The third one is calculate the value, that is tabulated value, and then compare and find out the result. So our first step is we need to frame the hypothesis. Okay, so our null hypothesis will be like the average life will be 400, which is average of individual customer pay, not average life, average amount and individual customer pay is 400 against, since it is nothing given, it is more or less. So in the question, we need to check whether it is 400 or not. So that is not equal to 400. If we are discussing about more or better, then it is wanted. In this question, it is not clear. We will discuss about like not equal to case. Okay. So this is our hypothesis. Okay. And here, since sigma square, standard deviation, sigma square is known. Okay. This quantity is just given randomly. No need to use that quantity, because when we are discussing about the mean, testing of mean, then either sigma square is known or sigma square is unknown case are there. So sigma square is known, that is 25. So in that case, our test statistic will be like sigma square equal to 25 is given. Okay, n is also given, that is 50.
Sir,
Okay, yes,
sir,
yes, yes,
the
yes.
sigma square is population variance, but here given standard deviation, no?
Okay, 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 yes, yes, yes. It is sigma is given actually. Standard deviation word is there. They are generally use sigma square, so that's why I'm a little confused. So sigma is given. The standard deviation is 25. Okay, so sigma is 25, n equal to 50. Okay, and okay, yes, and also like level of significance alpha is 0.05. Okay, and the x bar will be given like 250. Okay, so our test statistic is defined z, which is equal to x bar minus mu or mu naught, we may say, if it is on sigma on root n. Okay, so we can write like this, na? Root n comes out in numerator, so it will be like root n, which is equal to root 50. X bar is 250 minus mu is 400 on sigma is 25. Okay, these are written. So it's root 50 multiplied by minus of 150 divided 25, which is 25 and 150 will be cancel out, and minus 6 into root 50, that is 5 root 2 into minus 6, and here comes out the z value of z is approximate value of z is like 30 and 40. So this comes a minus of 42.426. Okay, so we've already calculated. It comes out to be around minus of 42.426. This value will be calculated. Okay, now since it is discussed like it is mod two-tailed, so in that case we check the modulus value. The modulus value of z will be like 42/426. This is our calculated value. Okay, calculated z is like this. Okay, now the next aim is we need to tabulate the value. Sorry. Okay, we need to tabulate the value. Okay, so the tabulated value at z equal to alpha by 2, which is equal to z equal to 0.025, is nothing but 1.96 for two-tailed case. Okay, and here we reject or accept on the basis of that. So here mod z is greater than z at 0.025, which means it is greater. So we reject the null hypothesis. Okay, this implies reject the null hypothesis H naught. And thus, like we can interpret like this. That means our question is like, no, claim made by the provider is either true or not. The claim is like average customer pay 400 rupees, okay, per month individually. So that means the claim made by the service provider, like the claim made by service provider is not correct. Okay. The theme of the question like this, na, the company has claimed something, we have got some sample, and with the help of the test statistics, we use and find out that the claim made by the service provider is not right or not correct. Okay. In a similar manner, we can solve different scenarios, different questions under different scenarios. Okay. Like the second question. Okay. The second question is like standards set by government agencies standards set by government agencies indicate that Americans should not exceed Americans should not exceed an average daily sodium intake, an average daily sodium intake of 3,300 milligram. Okay. The question is to find out whether Americans are exceeding this limit. Find out whether Americans are exceeding this limit. A sample of 100 Americans is selected. Okay. And the mean of daily sodium intake and the mean of daily sodium intake are found to be 3,400 milligram. Okay. Population standard deviation is as, and like population standard deviation is as 1100 mg. Okay. Use 5% level of significance. Conduct a test of hypothesis. Okay. Test the hypothesis. Our aim is to, okay, like one thing, just keep in mind, like we are discussing about the estimation, okay, like inference. And in point interval or testing of hypothesis, in all scenarios, we first select some random sample and on the basis of those sample, we will estimate or conclude. Okay, so there is always some values, some random samples are there. Okay, in statistical inference, always there is some samples. We discuss about the samples and then conclude about the parameter or population. Okay, so here the population claim is like this, and the sample, from the sample we get these as a numerical value, and then with the help of these values we check whether the population claim is either true or not. Okay, for this again, the first step, just frame the hypothesis, that is h naught. Okay, so its mu is less than or equal to 3300 versus h1, which is mu is greater than 3300. Okay, you may also write this. Okay, and like this. So try to stick with one kind and then accordingly proceed. So I'm stick with the first one. Okay, and then solve. So our hypothesis will be like this: mu is less than or equal to 3300 against the mu is greater than 3300 MB. Okay, so the test statistic, since again like standard deviation is given. So okay, so standard deviation is okay. The standard deviation is given. Okay, then we may write like this. This is this n equal to 100. So our Z statistic will be defined like this: root n x bar minus mu on sigma, which is it's 100 into it is 3400 minus 3300, and it is 1100. Simple calculation actually. We may solve this. 10 into its 100 and divided by 1100. So this comes out to be like 0.91 after solving. Okay. So our Z statistic will be the calculated value is 0.91. Now at level of significance alpha is 0.05. So that means Z alpha at 0.05. This value is 1.645. Okay. This value from the table is 1.645. So here we conclude that like Z value is less than Z alpha or Z 0.05. 0.05. So we reject H naught when it is greater. Okay. Reject H naught when it is greater. Calculated value is greater. So that means what? That means we fail to reject H naught. That means we fail to reject H naught. H naught is what? Like it is less than or equal to this. Okay. And we are not able to justify this. So this means what? The evidence to indicate that the average daily sodium intake exceeds 300. Okay. So there is no evidence. Okay. So we have rejected H naught. That is, there is not enough evidence that we conclude this. Okay. So we fail to reject the null hypothesis H naught. Either we fail to reject or we reject. Try to avoid the except word here. Okay. For standard notation, otherwise we may write like we accept H naught. Okay. So simple question. the third question will be like a random sample of size 16, a random sample of size 16 has 53 as mean. The sum of square of mean deviation deviation from mean actually from mean is 150. Okay, can this sample be regarded as, the question is, can this sample be regarded as taken from the population, having 56 as mean at 5% level of significance. Okay, try to solve the question with yourself as well. Okay, like the question is, we have taken a sample of 16 and find out the mean value is 53. Okay, now the sum of square of deviation about mean is also given, which is 150. So can this sample taken from this population, that the population has a mean of 56, okay, at 5% level of significance. So that means what? We need to test for sample mean. Okay. So that means what? Our the question, the first step, the framing of hypothesis. So given like n equal to 16 is given, the sample mean, which is x bar equal to 53, and the sum of square of deviation about mean is this. So that means what? Sum of square of deviation about mean, that is xi minus x bar. The deviation about mean xi minus x bar, the square is this, and the sum of square, that is summation from 1 to 60. This is given 150. Okay, we are given this. These are from the sample. And we need to check the value of mu is either 56 or not. So that means the hypothesis is mu equal to 56 or not. That means against the alternative hypothesis, mu is not equal to 56. So this is the case when we are going to test the mean when the sigma square is unknown. Okay. So that means that the second step is statistic. Okay. So the test statistic in this is T, which is defined like this: x bar minus mu upon S. Okay. This is our test statistic when sigma square is unknown, and we are discussing about the testing of mean. So this comes out to be like n equal to 16, x bar is 53, minus mu is 56, and S. Okay, now the S is what? So S is defined as like this, 1 upon n minus 1 whole square. Okay, this is how the S is defined. So that means S square is like 1 upon 15 into 150. S square is equal to 10. So the S will be root of 10. Okay. So that means we use the value here directly, root of 10. So again, it is 4 into it is minus 3 and root 10. Okay, so use calculator and find out. And after calculating, we find out the value is minus 3.795. This is the value of statistic. Okay, now the tabulated value P at n minus 1 degree of freedom, and since it is two-tailed, so it's alpha by 2, that is T at 15 degree of freedom at 0.025. This value is taken from the T table, and this value is about 2.13. Okay, now, okay, now if T is greater than or equal to T value, then we reject H naught. Okay, so the modulus value is 3, and that means the H naught is rejected. That is 3.795 is greater than the tabulated value. So this means we reject H naught. That is the given sample is not taken from the population having the mean as 56. Okay, we are testing this now. Whether this sample taken from the population having the mean 56. So no, it is not, because we reject the null hypothesis. Clear? Like if anyone have any doubt, please ask. Okay, and try to solve the question with yourself as well. We write question number 4, which is a man weekly sales. Sorry, mean weekly sales. Mean weekly sales of the candy bar in a candy store was 146.4. Okay, bars per store. Okay, after an advertising campaign, like after an advertising campaign, the mean weekly sale is the mean weekly sale in 22 stores for an increase to 153.7 and showed the standard deviation of 17.2. So the question is like, was the advertising campaign successful? Was the advertising campaign successful? At 5% level of significance. Okay, so the question, try to understand the question. We have some kind of assumption, some kind of hypothesis. Then we take some sample. The sample is taken from 22 store and find out the mean and variance is this. Now we need to check whether this claim is either true or not. Okay, and this is in the form of advertising campaign. That is whether the advertisement is good or successful or not. So again, the similar step. First, frame the hypothesis, evaluate the statistic, then compare with the tabulated value and conclude. So the first is like what we are given. So we are given like the 22 shops are there, n equal to 22. X bar is like 153.7. The standard deviation is like 17.2 and the alpha will be like 0.05. These are given already in the question. So our hypothesis is H naught, which is mu equal to 146.4. Okay, mu is like 146.4 and against the alternative hypothesis is not equal to, okay, not sorry, sorry. Like here in the question, was the advertising campaign successful? This is successful only if the average sales increases. Okay, we say that the campaign is successful if the average sale increases. That means it is not like this. Here it is greater than. Okay, just understand. Here it is we are discussing about whether the advertising campaign is successful or not. That means whether the weekly sales increases or not. So that means either it is equal to this or it is greater than this. So it is a one tail. Okay. So the next step is calculate the statistic, which is T and which is defined as like X bar minus mu upon S upon root n. So then will be numerator. So it is like root 22. X bar is like 153.7 minus 146.4 and it's divided by 17.2. Okay. So it is root 22 multiplied by 7.3 and 17.2. Okay, after just calculation, it is a simple thing. So you people obviously calculate. So T comes out to be approximately 1.96. Okay, 9695 something comes out. Okay, so our value will be like this. Okay, now this is our calculated value. Now the tabulated value is the T at degree of freedom n minus 1, that is, and the value of alpha is like 0.05. So that is T 22 minus 1, it is 21, and alpha is 0.05. And this value is taken from the table and find out it is 1.721. Here, tabulated value is less and calculated value is greater. Here, T is greater than T 21, 0.05. Okay. So that means, again, we reject null hypothesis. So we conclude we reject H naught. Reject H naught means reject H naught is that means this. Okay. So we conclude that the advertisement, that is like what? Like we reject H naught. We reject this. That means this is true. That is the average sale is greater than this. That means the campaign is successful. Okay. So like we claim that the campaign is success Clear? So this is how we are discussing or we are solving the hypothesis testing problem. The next question is, a sample of 20 observations gave a sample standard deviation of 3.72. Is this compatible with the hypothesis that the sample is from a normal population, that the sample is from normal population with variance 4.35 at 0.05 level of significance. Okay, so here we need to check the test for variance when mean is not known. Okay, up to this point we test whether the testing for mean is conducted when the standard deviation is either given or not given. Now from this question it is test for variance. So the given question is a sample of 20 observation, that means n equal to 20 is there. Okay, the sample standard deviation is like 3.72. Okay, and we need to test this. So that means our hypothesis is like sigma square. Actually, sigma equal to this. We need to check sigma equal to this. Sorry, variance is this. Sigma square equal to 4.35 against H1, which is we have taken sigma square is greater than 4.35. Okay. You may also take the less than, you may also consider the less than scenario. And on the basis of that, you may find out whether the hypothesis is accepted or rejected. Okay. So this is our hypothesis. Now the next step is test statistic. So in that case, we define the test statistic like this: W, which is equal to n minus 1 S square upon sigma square, when mean mu is unknown. So this is like n minus 1, which is 20 minus 1, S square, which is 3.72 whole square, and sigma square, which is 4.35. So it is 19 into 3.72. You may take the square of this, and it is 4.35. The final value, I'm writing the final value after calculating this, which is 60.44. The calculated statistical value is 60.44. Now, the tabulated value, since like chi-square with n minus 1 degree of freedom at alpha, so it is chi-square with 19 degree of freedom 0.05. So with the help of chi-square table, we will calculate this value is comes out to be like 30.144. Okay. So here the calculated value is greater than chi-square 19 at 0.05. Okay, so that means calculated values again greater, so we reject the null hypothesis. That is, we concluded that we reject the H naught. Okay, and what is H naught? H naught is this. Okay, so that means this sample is compatible with the hypothesis that the sample came from this population with variance this. So no, that means we conclude that the random sample is definitely, so the random sample definitely not compatible from the normal population with variance 4.35. Okay, so that sample is not taken from the population having the variance 4.35, which is normal. So we conclude this. Okay, so this is how we are discussing about the testing under different scenarios. Okay, now the next question will be like, weights in kg of 10 students are given. Okay, weights in kgs of 10 students are given, which is given like 38, 40. We will write in tabular form later. Now the question is, can you say that the variance of distribution of weight of all the students from which the above sample of 10 students was drawn is equal to 20 kg? Okay, so let me write the question. Can you say that? Can you say that the variance of distribution of weights of 10 students was drawn is equal to 20? Is equal to 20 kg at 5% level of 5% level of significance. Okay, so again we need to check the variance to test the variance. So that means we need like something. Also the mean is not given here as well. So when mean is not there, so what is given here, like let me write a table first. Okay, the values of xi is like this: 38, 40, it's 38, it's 40, it's 45, 53, 47, 43, 55, 48, 52, 48, 52, and 49. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the weight. Okay, weight of 10 students. Okay. Now the next thing is we need to discuss about the okay. H naught is like what? We need to test the variance, which is either 20 or not. So and the mean is not given, in that case the test statistic is like this. Okay, n minus 1 s square upon sigma square. Sigma square at 20 we need to check. N is given 10, s square. Now s square we first need to calculate s square, which is 1 upon n minus 1. That is summation psi minus x bar whole square. So that means we need to first calculate this quantity, x bar. X bar is 1 upon n summation of xi. Okay, so from here, when we add these, it comes out to be like 470. Okay, the sum of xi's are 470 and the value of n is 10. So that means 1 upon 10 into 470, it comes out to be 47. Okay, so our next column will be like this. It's xi minus 47, which is xi minus x bar also. Okay, so now it is 38 minus 47, which comes out to be 9. 40 minus 47, 7. It's minus 2. It's 5. It's 0. It's minus 4. 5. It's 8. It's 1. It's 5 and it's 2. Okay. Now the xi minus x bar whole square, which is 9 square, that is 81, 7 square, 49, 2 square, 4, 5 square, 25, 0, 16, 64, 1, 25, it's 4. Okay. Now the summation of xi minus x bar whole square is comes out to be 280. After summing, you will find this. So x square is what? 1 upon 9 n minus 1, which is 9 into 280. And this comes out to be approximately, no need to solve this, na? We may directly use. So it's n minus 1 s square is what? 280. From here, it's n minus 1. Na? It's n minus 1 s square. And it comes out to be 280. So our numerator value is 280 and denominator value is 20. So our test statistic W is n minus 1 s square upon sigma square, which is 280 upon this is 20, which comes out to be 14. The calculated value is this. Now the tabulated value. Okay. Now the tabulated value is like chi square, and the degree of freedom is n minus 1, which is 9, and alpha is 0.05. So at this, the chi square value is 19.023. So that means here W is less than the chi square, less than the chi square at 0.05. This means we fail to reject H naught. Okay, that means what? We fail to reject H naught. That means this 10, the weight of 10 students is taken from the distribution with the variance is 20. Means this data, this xi's are taken from a distribution whose variance is nothing but 20. Okay, that means this. So like we may conclude that the variance of distribution of all the students in the population is 20. Okay, so this means now the next question. The next question is like a random sample of 20 daily workers random sample of 20 daily workers of state A or state A was found to have an average daily earning of rupees 44 with sample variance sample variance 900. Okay, another sample is another sample of 20 daily workers of state B was found to earn an average of rupees 30 per day with sample variance 400. Okay, now the question is test whether the workers in state A are earning more than those in state B. Like test whether the workers in state A are earning more than state B. Worker in state A are earning more than state B. We need to test this at 5% level of significance with or for, there is one condition, for equal population variances. Like when we are discussing about the two sample problem, then there are three possible cases. When sigma square is known, and when sigma square is unknown, there are two subparts are there. That is unknown and equal, unknown and unequal. So it is unknown and equal case. Okay. So similarly, like again, we are given like this. Suppose like these are state, this is sample size, this is mean, and this is standard deviation. Okay, since sample variance is given, sample standard deviation small s, sorry, capital S. So suppose A has 20, which is the value of n1, and the mean is like 44, and the standard deviation is 30 because 900 is sample variance, so 30. Standard B 20 is also there, which is n2. Like x bar is there, y bar is like 30, and it is 400, that is 20. Okay. So hypothesis will be like, we need to test is state A are earning more or state B? Okay, so we just tried one condition like mu1 is less than mu2. You may check mu1 is greater than mu2 as well, and the rest of the thing are accordingly changed. So mu1 is less than mu2. We need to check this against mu1 is greater than mu2. Okay, this is equal to as well. Okay, so for this, the test statistic is when mu is unknown and sigma when sigma square is like equal. Okay, in that case, the test statistic will be like E is n1 n2 upon n1 plus n2, and it is like x1 bar minus x2 bar or x bar minus y bar upon sp. Okay, so first we need to calculate sp. Sp square will be like n1 minus 1 s1 square plus n2 minus 1 s2 square upon n1 plus n2 minus 2, which is equal to what? 20 minus 1, which is equal to 19 into s1 square, which is 900, plus again 19 into 400, and n1 plus n2, it is 38. 20 plus 20 minus 2, 38. Now it is simple. You may solve this. Let's write one more step. It's 17100 plus it's 7600. It's 38. Although you may divide 38 by 90 and then work on. So overall, we find out it's 650 actually after solving sp square. So the value of sp is under root of 650, which is approximately 25.495, or we can say that 25.5. Okay, so the value of sp is this. Now we are given x1 bar, x2 bar, n1 and n2. So the statistic T is n1 into n2 upon n1 plus n2 into x1 bar minus x2 bar, which is 44 minus 30 upon SP, which is 25.495 or 25.5. Okay. Okay. Yes. So this can be like 10, root 10. This one is root 10 and this one is 30, 44, just wait. Okay, this comes out to be like 7. Okay. It's 14 and divided upon 25.495. I think there's a calculation mistake in my rough sheet. So sure, you people get right. My value is approximately like 1.736. Okay, make sure it is correct or not. Okay, so suppose we have got some value and my value is like 1.736. Now the t value. Now the t value at degree of freedom n1 plus n2 minus 2 at alpha. So this value is calculated like what? T is 38 and alpha is 0.05. And this comes out to be 1.685. Okay. So here the t value is this, which is greater than t at 38, 0.05. So that means again calculated is greater. So we reject the null hypothesis. we reject the H naught. And what is H naught? H naught is this. So that is, we accept the alternative hypothesis, that is, this one is greater than this. So that means what? That means country A, mu1 is country A. Country A are earning more than that of country B. So this is clear. Okay. Now the next question is, okay, the next question is, the local baseball team conduct a study. The local baseball team conduct a study to find the amount spent about refreshment at a ballpark. At a ballpark. Over the course of the season, over the course of the season, they gather simple random sample. They gathered the sample of 100 men and 100 women. Okay. Now, from these random samples, we got some information. What? For men, the average expenditure was $200. For men, the average expenditure was $200. Okay. Average expenditure was $200 with standard deviation of $40. Okay. The similar for women, the expenditure is like $190 with standard deviation is $20. Okay, so these are the information. Okay, now the team owner claim that the men spend more than women. Okay, so check test of hypothesis at 5% level of significance. Okay, so let me write the whole question. The team owner claims that the men spend more than women. Okay, check the hypothesis. Check the hypothesis at 5% level of significance. Okay. Again, there are two sample problem. So we have either unknown or known sample variance and population variance. So it is like assume like population variance are unequal and unknown. Okay. In the previous one, the population variance are equal and unknown. And in this case, we are discussing about the unequal. Okay. So similar manner. Like, let me write in the next page. Like there is man, there is woman. Okay, so the sample size, the sample mean, and the sample SD. Okay, so the N1 equal to 100, N2 is also equal to 100. So sample mean is like 200 and $190, and the sample standard deviation is 40 and $20. Okay. Now the first step is, these are given information. The first step is frame the hypothesis, which is H naught, which is mu1 is less than or equal to mu2, or mu1 is greater than or equal to mu2. Actually, in this question, we need to check this. So we will equate it mu1 equal to mu2 or mu1 is less than or greater than condition against H1, which is mu1 is greater than mu2. Okay, we need to check na, whether man spend more. So that means what? This is man spend more. Or in null hypothesis, we are only in neutral. That is mu1 equal to mu2 or mu1 is less than mu2. Okay. So yes, these are our hypotheses. Now the test statistic under this condition is like, it is x bar minus y bar whole upon, if you people know, s1 is square upon n1 plus s2 is square upon n2. Okay, so x bar is 200 minus x, y bar 190. S1 is square is like 400. Sorry, not 400. 40 square upon 100 minus, sorry, plus 20 square upon 100. So it is actually very simple. Now it is 10 upon 1600 upon this. This is 16 plus 400 up, it is 4. So 10 upon root 20 is this. It is 10 upon root 20. So it is a approximate value of this is approximately 2.236. Okay. So our calculated value of T statistic is 2.236. Now, under this condition, the degree of freedom is calculated, which is approximately 1.4146. Okay, let me write it then. Okay. Now degree of freedom is S1 is square upon N1 plus S2 is square upon N2 whole square, and S1 is square upon N1 whole square plus S2 square upon N2 whole square, and like this is divided upon, it is like N1 minus 1, it is like N2 minus 1. After solving, just try to put all values. It is like 40 square upon 100 plus it is 20 square upon 100. This is whole square actually, and then divided upon like 40 square upon 100 whole upon 100 minus 1 plus again 20 square upon 100 whole square upon 100 minus 1. Just a simple calculation, nothing like very deep. And after solving, just let me write the value directly. So after solving, we will find it approximate value is 146. Just put the value and solve. You will find approximate value is 150, 145 point something, which near comes out to be 146. Okay, and alpha is equal to 0.05 is given. So the t value at 146 and 0.05 is comes out to be like 1.655. Actually, 146 is a very large number. And then when n tends to infinity, like for large n, the t distribution and the z, the normal table, have the same value. So it is approximately the normal value. You may use the normal table or the t table as well. Okay, so we come to 1.64 and our statistic is 2.236. So that means our t is greater than, so that means again the calculated value is greater than the tabulated value. This implies we reject H naught. Actually, I'm frame all the question in such a way that when the calculated value is greater than the tabulated value, we reject H. Okay, when you consider the H like it is greater than or equal to and it is less than, then the scenario is changed. Okay, but I'm trying to stick with the same format all the time. Okay, so there is no confusion after tabulated or calculated section. So if tabulated is greater, less than, and the calculated is greater, then we reject the H naught in these scenarios. Okay. Okay, that means we conclude that men spent more than women. We reject H naught. That is, this is not the right one. That means this is the acceptable one, which means mu1 is greater than mu2. That means men spent more money than that of women. Okay. Now the next question is an IQ test conduct on to 5%. Okay. An IQ test is conducted on to 5% before and after they are trained. Okay, that is we first calculate or like evaluate the IQ of those 5%, and then after a certain amount, certain training, we again calculate the IQ of those 5%. Okay, and we have a data. Let me write the data. Then we need to test whether like the data is like this. Okay, I write the data in a tabular form in letter. We need to check like what? Test whether there is any change in IQ after the training. We need to test whether there is any change in IQ after training. So similarly, at 5% level of significance, we are already known. So our data will be like this. Okay. So let me first write the data, and then we will frame the hypothesis and the test statistics will be calculated. So it is XI. The data is like XI. XI is IQ before training. IQ before training. This is XI. It is 110. The 5% are like suppose candidate 1, candidate 2, candidate 3rd, candidate 4th, and candidate 5th. 110, 120, It's 123, 132, and 125. These are the IQ before training. And suppose YI after training. Okay. And this is like 120, 118, 125, 136, and 121. Okay. So these two are the data before and after training, the amount of IQ, the IQ measure. Now, since this is a paired test, so we need to calculate. Now we need to frame the hypothesis. Na? Okay, so the hypothesis is like H naught, which is we need to test whether there is any change. So that means what? There is either any change, either there is no change. So that is mu1 minus mu2 equal to 0, or we can write it like this, mu d, which is mu1 minus mu2 equal to 0, against the alternative hypothesis, which is not equal to. Okay, so mu1 minus mu2 is not equal to 0, or mu1 is equal to mu2, or mu2 is not equal to 0. Okay, so our hypothesis is like this. Okay, yes. Now our test statistic. Our test statistic is this. Okay, where d is xi minus yi, d bar is 1 upon n summation xi minus yi, and hd is 1 upon n minus 1 summation xi minus summation di minus d bar whole square. Okay, we will calculate this. Then the first step is to calculate di, which is xi minus yi, and this is 10. It is minus in 10. It is 2 minus 2 minus 4 and plus 4. Okay, so we need to find di. It is minus 10 summation di, and di square, which is xi minus yi square. It is 100, 4, 4, 16, 16. 100 and okay. Okay, let me write one thing. It is not this, na? I make a mistake. It is di square. Okay. Di, I don't need to calculate this. We need to calculate di minus d bar, na, for SD. It is di minus d bar whole square. So d bar is what? 1 upon n summation di. It is 1 upon 5 into minus 10, which is minus 2. Summation di is minus 2. So that is minus 2 minus plus 2. So it is minus 8 is equal to 64. Minus 2, 2 minus minus plus 2. So it is 4 square. It is 16. Minus 2 plus 2, it comes out to be 0. Minus 4 plus 2, it comes out to be minus 2 square, which is 4. 4 plus 2, which is 6 square, which is equal to 36. 40, 100, 100 and okay, 80 and 40, 120. So it comes out to be 120 after summation. Okay, these are simple calculation. So SD is what? SD is 1 upon n minus 1 summation of di minus d bar whole square, which is equal to 1 upon 4 into 120, which is equal to 30. Okay, so we have d bar, we have SD. It is SD square actually. Okay, so our t statistic is like the statistic root n d bar upon hd, which is equal to root 5 t bar equal to -2 upon root of 30. Okay, so it's a simple root 2 -2 upon root of 6, which comes out to be, after solution, it comes out to be minus of 0.8164. Okay, so this is our t calculated value. Now, the tabulated value of t is t at n-1 degree of freedom and at alpha by 2, because we are discussing about not equal to term. So t at 4, 0.025 is comes out to be 2.776. Here, modulus value of t is equal to 0.8164, which is less than the t value at 4.0.025. So calculated value is less than this value. That implies we fail to reject H0. That means fail to reject. That means we accept. That means the difference between these two is 0. That means there is no significant difference between the IQs of student before and after training. So there is no benefit of training actually. No? So this can be calculated with the help of these data. Okay. So like there is one question more. The question is two sample of size size 9 and 8. Give the sum of square of deviation from their respective means. Respective means equal to 160 inches, 160 inches and 91 inches. Okay, these are given. Now, can they be regarded as drawn? Can they be regarded as drawn from the two normal population? Drawn from the two normal population with the same variance? The same variance at 5% level of significance. So the question is, can they be regarded as drawn from the two normal population with the same variance? Okay, that means we test the sigma 1 square equal to sigma 2 square case. Okay, so our hypothesis will be like this. Like H naught, which is equal to, which is the sigma 1 square, the standard deviation of, sorry, the variance of first population is equal to the variance of second population. against the h1, which is sigma 1 square is not equal to sigma 2 square. Okay, we are given like n1 equal to 9, n2 equal to 8, and the respective means are also given. Not the respective means, the sum of square of deviation from their respective means are given. That is summation of xi minus x bar whole square is given, which is 160, and also yi minus y bar whole square is given, which is 91. And it is like, let me write it, j from 1 to 8, and it is I from 1 to 9. Okay, so these are clear. Now we need to test this. So the test statistics for this is f, which is s1 square upon s2 square, which is the greater one or the larger one, will come up in the numerator. So first we need to calculate s1 square and s2 square. Okay, then now s1 square is what? 1 upon n1 minus 1 summation of xi minus x bar whole square, I from 1 to 9. So that means 1 upon 9 minus 1, 8 into 160. This comes out to be 20. Similarly, s2 square upon 1 upon n2 minus 1 summation j from 1 to 8 yj minus y bar whole square. So n2 equal to 8, so 1 upon 7 into, it is 91. So this comes out to be 13. So now the calculated value, the test statistic is like s1 square upon this. So it is approximately 1.54. Okay, now the degree of freedom. Now the f value at n1 minus 1, n2 minus 1, and it is like not equal to k. So alpha by 2. That means f of n1 minus 1 is 8. 870.025 is, with the help of f table, we will calculate it and find out to be 4.899. Okay. So here, or either modulus value or not, so 1.54 is less than 4.899. So in this case, we reject the H naught if this. That means what? That means again, we fail to reject H naught because calculated value is less and tabulated value is greater. So we fail to reject H naught. So thus we claim that the two samples are drawn from two normal populations with the same variance. Okay, so we conclude this. Okay, in a similar manner, there are actually 5 or 6 more question is there, but unfortunately time is not there. So anyone have any doubt, he or she may ask. If not, then I think you people know, no, there is one more extra class. Anyone know about this? Can anyone confirm? Am I audible? No? Hello.
Hello.
Yes.
No doubt, sir. Everything is clear.
Okay. No. My question is, do you know there is one more class, one extra class is there? Do you
Yes, sir.
people got
Tomorrow.
tomorrow? Do
9.
you got any mail?
Yes, sir. 9 to 10. 9
Okay.
a.m.
The
to
mail.
10 a.m. for tomorrow.
Okay. So we will discuss some more questions, and tomorrow 9 to 10 morning there will be a session. Okay. Okay. Anyone have any?
Okay, sir.
Okay, then I think we should stop here. Let me stop the recording first.